actually view my videos will use this. So hi, 3 people on the internet and my class. To do chi-squared, we need, for this one, ns, confidence interval, alpha divided by 2, chi-squared left, chi-squared right, critical, if I could spell, left, critical, chi-squared right, top part, because I like checking and doing stuff, and then I can do lower and upper. Well, okay, I don't technically need top part, but the formula, I do that because it's used in both formulas. So, these come from tables, but I use something else. So the top part of the equation is going to be degrees of freedom, or so it's actually n minus 1, which is your degrees of freedom, times s, I don't like to do that. That's what we do things. N minus 1 times s squared. And the bottom part would be the square root of n minus 1. Oh, sorry, not n minus 1. It's top part of, or square root of top part divided by critical x to r. And this would be square root of top over x to left. That's how you find all this stuff. So on an example where we have a 98% confidence interval, 0.98 here, 988 here, and a sample size of 21, and an S of 0.24, we need to find all this nonsense. Oh, these are one over. So, oh, sorry, these are one down. These actually come from tables. This is calculated from, oh, sorry. So, these are tables. These come from 1 minus alpha divided by 2, and this would be alpha divided by 2. That's where those come from. So alpha divided by 2 is going to be, and here, equal to 1 minus my confidence interval. Yes. 1 minus B3 minus B3 divided by 2, which gives us that. So this is just that value there. And this will be 1 minus that value. Easy enough so far? Yeah. So these two here use different functions. It's just where it gets kind of weird. So this, actually no, it's the same function, but it's kind of weird. So I use chi-square dot inv dot right, and I use, this one uses the left, and it uses degrees of freedom, so which is B1 minus 1, comma, which would give us our critical value. Then the other one is the same thing. Chi-squared inv dot right of, then we do this, and then our B1 minus 1. Make sure they're right. Okay. That's our critical chi-squared values. So far, the only thing I've had to put in are these. Where's my stuff? So the top part. So that's going to be equal to n minus 1. So this minus 1 times this squared. The reason I do that, again, is because that's used in both of these functions. And it's easier just to have one function or one value to call, one cell to call, than everything else. So my lower confidence interval is equal to the square root of this value divided by, let me see, make sure I get the right one here. B8, so the bottom value. And this is equal to square root of this divided by your left. And that should be your upper and lower confidence intervals. So let me make sure that they're right here. 21, hey, wait, what? Oh, 20. Don't you hate it when you know the answer, you put the wrong one in and it tells you you're wrong?
Okay.
Left, 0. I hate rounding the 3 decimal points too. Please. 6, yes. So my upper and lower is 0.18. And then here, let's change it to a different decimal place. At the very end. At least. That is correct. Verified by putting the answers in here, so it's 100% correct. Yeah, it was 23. So the chi-squared is 23, 24. It will all run the same basic chi-squares. Basically. Yeah, because you know they run like 3 or 4 of the same problem types. So that's how you do it. And the only 3 you have to put in are your sample size, your S, and your confidence interval. And everything else will just literally pop in. Yeah. The other one I figured out how to do, and it's kind of annoying. I figured out how to do is the bootstrapping. I got it. I got it. I think so. The one with the like 200 sample size. Yeah, I got that. I got it. Believe it or not, once I saw what they were doing, it's like, okay, that's not hard. It's just annoying, not hard. Okay, so let me see the data center. So we have this data, and they took bootstrapping samples because life is pain. Let me copy this to the clipboard. Open Excel. No, that's okay. Hey, look, a lot of samples. So you have to find the mean of all these guys. The easiest way to do this. Actually, you know what I'm going to do? Watch. Can I still do this? Will it let me a special? I can't. No, okay. It's going to sound weird. I don't want them this way. I want them transposed. Really? Oh, edit special. I know shortcut. Really? You're gonna do this to me. Transpose it down here. Thank you. X. So there's a method to my madness, mostly because I don't like going down. And I'm going to need these. So I find it easier to work this way with this data. I can even do it more fun. Because what it lets me do is, so sample, go over here, and this is kind of important because it's going to save you a little hassle. So we want to find the average of everything. So the B2 to P2 should be. Yep, B2 to P2. And then I find them all. So the first thing it's going to want you to do is to, oh no, I just want the bootstrapping interval. So this is going to sound very weird. What you need to do, highlight everything, go to data, and hit sort, and say my column has data headers, and sort by the mean. And I want smallest to largest. What this does is it sorts by smallest number to largest number. So from here, we have to find 5% on the bottom and 5% on the top. Which is, or 2.5% on the bottom, 2.5% on top. So 200 times 0.025 is 5. So 1, 2, 3, 4, 5. But since we have an even number, and you guys remember so well, all the way back to the beginning of the semester, we actually have to find between those two, right? And then we do the same thing. And then 5 is 195th. So 1, 2, 3, 4, 5, X and X. So what we have to do, average these two equals average those two. And that's our bottom, that's our 5%. So here it'd be 3.63. And go down here. And do it again. Which should be about 4.14. Maybe 4. Yeah, 4.14. Why is it giving me different answers? This worked before. 6.3. What? It should be correct. For some reason, I'm getting answers that are slightly different. 1, 2, 3, 5. I don't know why. It's saying my correct answer is 3.67 and 4.12. And it makes no sense unless it's supposed to be. No, I don't know. That makes no sense. Oh, this is 90%. So this is for 95%. To make sure you watch out for your confidence interval. That's why I'm getting this wrong. 90% would be 10. So yeah, 10. 1, 2, 3, 4, 5, 7, 8, 9, 10. So between these two, so it's 3.67, and down below, $4.12. And generally speaking, these are going to be narrower than your t-interval. That's the whole point of bootstrapping, is to narrow your interval. So without even doing the math on the other one, if you bootstrap and it's any decent sample size, that number's going to shrink. So my main error, what I did wrong with this one is I had a 95% confidence in 95% confidence interval, and they wanted a 90. Let me guess. Everyone who was working on that did not do that at all. And you would never have thought of doing that, right? Yeah. You would have done the normal one with standard deviations, and yeah, no. I did the same thing, and it ended up being very, very wrong. That is right. That's right on here. I could, if I really was motivated enough, which I'm not right now, get up another program and verify it, but that would take work and effort, and I don't really feel up to it right now. So those are the two ones. Those are actually the last two main topics on here. What?
Those are literally the ones we get questions on.
The only thing, I mean, those were the annoying weird ones, right? And yeah, it took 40, 50 minutes of me like, the heck do they want? So, and yelling and screaming at it, and while I drank hot chocolate. So that's done. Cool. Gonna remind you once again, hey, you got a project coming up. Yeah, I know your homework's due soon, but you have a project coming due in 1, 2.
Yeah, I'll probably just like.
Remember, I have my timelines are slightly different than Cloud. So if you could finish it by the 23rd, I'd be okay with it, because that's right before class. I will go ahead and let you get it to them, because I figure you should have to the end of, right before class. I think they assume that you're going to have a Monday class, and you don't when they build it. But I don't have it. Yells at me whenever I try to change dates. So yeah, do that. Hey, online people, do that. What, you're gonna start doing part 2 next week?
Yeah, my plan is I'll just do one part
Every week, and make sure you get it right, and then probably bug me about the actual text and what your interpretation is.
Yeah, because that'll give us plenty of time to spare.
23rd, before the 24th. So before class that week. So like before the last week of class, essentially, because the 31st apparently the 31st is our last day of class. In person.
It's like a whole month before the last day of this semester.
2 weeks. 2 weeks and a day.
It's like on
The 16th.
the portal says that the 21st was the last day of the semester.
Yeah. Okay. So I don't know why they did it, but the 31st. The first is the first day of transitioning to online, and then the last 2 weeks, so 7th, 9th, 14th, and 16th are online. And then after that, it's your optional spring break. Yes, I did. Yeah. Okay, so what else do we have?
That was it for me. The last question I only had was, how do you know when you're supposed to use like the Z distribution?
So Z distribution, that's a weird one. That's always a weird one. I'm going to make sure, because what I end up doing if I don't understand that. So a population versus sample. If you're doing a Z, you have a population standard deviation. T-distribution, you have a sample. So that's the main difference. Like I know there was a very simple one, and I hate to say it, I did Google it. It actually came off of Jump, but even then you had to actually answer it. Why is Google going off? Oh, because I said I Googled it. Stop spying on me overtly. Yeah, it will. It will. Oh no, actually, if you look at it, the main difference is, if you look at a Z table, pull one up, is this guy, right? Remember this thing? Where you have, let me actually pull one up. Is this huge thing where you have your, this is a Z table. So you have your Z score and your percentage based off of it. A T table, on the other hand, is based off of degrees of freedom. So it's dependent on your sample size. So even reading the tables is completely different. And it gives you different values. And then this will give you your critical value based on your sample. And the bigger your sample, the smaller your t-value is. Because I mean, 636, kind of a massive number. So generally 0.05 for one tail or 0.5 for two. So you end up knowing some, not on these, but especially on these, I don't care. Especially on these guys, you know a lot of these values. Well, you joke. That happened. Yeah. It was one of my ex-professor, he passed on, was doing a test on a GMO tobacco plant that was resistant to a pathogen. So you had growth on it. One of them was perfectly fine. The other one was dead. You can achieve 636 with that. Like you joke, but I present that. A population of two, one is alive and one is dead. I mean, you don't really need a statistical test at that point. You just show pictures of it. Guess which one is the one that's resistant? It's the best results, right? It's dead, it's not. So yeah, that's the thing is about statistics. Sometimes, yeah, it's nice to have the big fancy numbers, and sometimes you show a picture. Which one do you want? The dead one or the not dead one? Depends on what you actually wanted out of the whole outcome, but that's beside the point. So what else do we do? Was there any other questions either from Zoomland or from YouTube? And I mean, like we've done 2 or 3 questions each time. It's just, I literally had them queued up so I have any of those random sides. 24, 25. Oh, those are the ones I just did?
Yeah, the
Chi-squared ones. Those aren't even the real ones. That's the thing. These are just with like population variances and stuff like that. But you're not even running real tests with people or anything like that because you do different things. But I think that's the next unit, next topic. So, but like I said, you should probably, so your next homework is actually due at the same time as your project. So I would highly suggest spending more time on your project than your homework,
Okay.
because your project is worth significantly more than your homework.
Yeah, we got it all planned.
So for this upcoming week, because of the way my schedule has flipped, if you want to bug me, Friday at 7:45, not Monday at 7:45, because my online class got flipped around because of a quiz today. So if you need me, Friday at 7:45 will be the best time to get a hold of me. In the morning, I will be very giddy that day, so that's all you have? You have online people, do you have anything? Or is that, I mean, I think I've covered everything for that whole unit over the whole, or the homework topic for the whole 2 weeks or so. Do you guys have anything or no? I mean, speak now or forever hold your peace, and I'll end the meeting. I am probably going to.